good night. I'm telling it because we have people from all over the world. So welcome on the webinar of Adamus SA. My name is Artur Jakubiak. I'm a development director here in Adamus, working in the business of compression tooling from 16 years. So I'm really glad to have an opportunity to give you some hints regarding the multi-tip tooling. And of course, this is a fascinating subject, but because we have a quite limited time, I will be able to tell only about the few things. Of course, you can ask the question later on, but from the technical reason, because we have a quite many participants, I think that we should answer the question from the limited time, let's say half an hour after the presentation. Of course, if you put your question in a chat here in the presentation, and even if we will have no time to answer those questions, of course, we will answer them just on the writing form or emails. You can also feel free to just drop me the email, and I will answer all your questions. So after this very short introduction, I would like to start with the subject of today's presentation. So the merits of the multi-tip tooling. And of course, as you can see during the presentation, this is generally the way to increase the productivity of the tablet compression. So generally, with the modern tablet production, this demand for improved productivity together and in the same time reducing the manufacturing cost is a, let's say, dominant factor today. And this growing demand for increased yield, you as a manufacturers must use a method to meet this requirement and address the problem correctly. So generally, as you all know probably, this is two main methods to increase, or maybe three different methods to increase the productivity of your tablet or tablet production. So of course, the simplest one, you can buy the new tablet press. The second is to increase the number of the station in the existing tablet press. So using the different tooling, you can increase the capacity. So here in this table, you see the different comparison of these same tablet presses with the different features, let's say. So we are increasing the number of the stations, like you see here for FETA 2090, for example. You can go for the tool standard Euro B. And when you are starting to decrease the die external diameter from B to BB, because B has 13.16 millimeters diameter. So if you reduce this diameter to 24, so this is a BB dies, you can increase the number of the station. Of course, then you have the possibility even more. So you can decrease this diameter to 22, would be BBB dies, or BBS 21 millimeter. And now you are already on the limit, because then the limited factor would be the size of the shaft itself. So you can go no farther with the decreasing the die size with the same, of course, B type of the punches. So generally, you see here the theoretical capacity. So you see how much we can increase by increasing the number of the station. Of course, in case of FETA, you see that you have also FS12 tooling. So this is a small tooling with 12 millimeter of the shaft diameter. So then in this same tablet press, instead, for example, 43 station, you can have 66 stations. So you increase, or you can double the capacity almost. Then the third method, it is using the multi-tip tooling. So here you have some comparison for 2 tips, 4 tips and 6 tips in the case of the Synthesis 50 of Kilian. So you see that using these same station numbers in the turret, you can increase the capacity of the produce tablet by some factors. Of course, here we have some, let's say, theoretical, very conservative factors. Why they are not equal of the number of the tips, I will tell about that later. But you see here that for 2 tips, you have a factor 1.5. For 2 tips, for the 4 tips, 2.8. For 6 tips, 4.5. So just by using the different tooling in this same tablet press, you can increase the number of the produce tablet significantly. Of course, we can when we will talk only about the multi-tip tooling, we can tell that this tooling transformed the way tablets are produced, and for nowadays, this is the most productive form of the tablet manufacturers. Of course, I can tell you that multi-tip tooling is nothing new. So it was invented in the end of 19th century, when only one-station tablet presses were available. So just to increase the productivity, the producer has no other choice like to use the multi-tip tooling. Then, when the first tablet press, rotary tablet press, was introduced in the beginning of 20th century, I mean, with the 16 station, then, of course, the people stopped to think about the multi-tip because the increase of the capacity on that time was enormous. Later on, of course, this multi-tip tooling went back to the industry because the people run for the higher productivity. So generally, the simple process of adding multi-tip tooling to existing machines can have a huge impact on the production through the increased output and reduce production time. Of course, without the necessity and expenses to investing in the new machinery. What is the advantages of the multi-tip tooling? Of course, first of all, increase the productivity. So generally, we can say that the number of tablet per turret rotation is multiplied by the number of the tips. Here it is just a remark, because in the table in the previous slide, you saw that we are using 1.5 for 2-tip tooling, 2.8 for the 4-tip tooling. Just this is a conservative values, and of course, when we are just counting only one revolution of the turret, we have to multiply the number of the tablet by the number of the tips. But in the time, usually we need to slow down a little bit with the revolution because of the increasing demand of the filling the die holes. About that, I will tell some more things later on. So generally, increased productivity. Then no large capital outlay for the new tablet presses. So it means that higher tooling cost, because of course the multi-tip tooling costs a little bit more, maybe even significantly depending on the number of the tips. But these costs are easily outweighed by increased output. Then we of course have a reduction in press run time per output of the tablet, which means that you need less maintenance, which is required per batch of the produced tablets. And of course, you have the reduction of the press setup time per output when you calculate that for the output of the tablets. Because we have the multi-tip tooling, so you need less tablet presses to satisfy the output which will satisfy you. Therefore, you need the less floor space, which leading to more products processed per square meter. And of course, all above advantages leads to reduction, sometimes significant reduction of the overall plant running cost. And of course, the question is, can we use multi-tooling in every tablet press? Well, from my experience, the answer is yes, even with the pretty old tablet presses from 60s, 80s of the last century. You can use multi-tip without any problem. But of course, we have some requirements which we put on the tablet press to be able to operate. So first of all, this tablet press must be in the good working order with no significant wear, especially in the turret area, including the punch guides, keyways, and die pockets. The second, the cams should be replaced if you have any significant signs of the excessive wear or degradation because you need to prevent damage to the punch heads. Then the upper turret must have a keyway in the guide to ensure alignment with the tooling. Of course, this is mostly requirements for the upper turret or upper punch table, okay? For the lower guide, it is not necessarily because you know that the punches, because you should treat the multi-tip punches as the shape punches. So, of course, you need to have a keyways in the upper punch because the upper punch must fit to the die. Lower punch is always on the die, so it's guided by the die. But we have some risk, let's say, because I just show you the double tip punch and the lower one, and you can imagine that those tips are in the die. So if you have no keyway, this is guided by the die, but with the action, with the compression roll or compression roll, then the punch has a tendency to turn. And of course, we have a lot of stress here in the tips and a lot of stress between the tips and the die wall. So what it means, after some time, okay, it could be 1 million tablet produced, for example, 50 million or 150, but then this is a mechanical piece. So when you have all the time the stress, then you risk the fatigue breaking, because as every mechanical part, the steel has a fatigue breaking. So then you are risking the breaking. So if you have the key in the lower punch, so it means that all the stress is just on the key. Of course, this is not ideal solution, because if you have here the stress all the time, after some time you have some damage in the keyway. So it means that the punch after the long operation will have too much place to move, and again it could go with the stress to the tips. So of course the ideal solution, especially if you have small tablet diameter, let's say less than 8 millimeters, would be the rotating head. About the rotating head I will tell you something more later on, but generally this is a model, okay? So generally you have when you have the punch which is kept in the same place by the die, Then in the action of the compression roll, the head will turn. So all the stress will go to the head. So this is the best solution indeed, just to prevent the fatigue breaking. Okay, so what else regarding the press requirements? Of course, attention should be given to the feeder paddles, as they may have to be modified, because you have a different shapes and of the feeder paddles, because you need to ensure the amount of formulation is correct for the die filling, because generally the different products just flow differently through the tablet press, and here you need to put more product in a one die because you have a couple of the holes. So of course you need to test also ejection system, because it has to receive larger production volumes, and the rest of the equipment associated with the tablet press, like, I don't know, for example, metal check or the duster needs to just take off the larger tablet capacity. What is the consideration regarding the multi-tip tooling? Of course, the formulation which you plan to compress with the multi-tip must be investigated, mostly because of the filling properties, because needs to flow relatively good through the tablet press. So the granulation that is not flowing quickly enough can result of the problem. So again, you need to look, or we can solve this problem by modifying the feeder mechanism to optimize the press speed, or alternatively, as I said before, you can slow down with the revolution of the turret, just to give enough time for the die going under the feeding or under the feeding area, just to have enough time to fill up correctly. Generally, multi-tips can produce most tablet design, but of course, depending on the size of the tablet and the standard of the tooling you are using, it can be calculated how many tips you can use. So generally, shapes such as ovals can be more challenging to arrange while delivering a robust tooth, or any of exotic shapes, let's say, because first of all we can have the problem with the mechanical stability of the tooling depending on the shape of the tablet, but also we need to take into consideration the way after ejection when the tablet hit the tablet scraper, because here we have not only one tablet but we have a couple of them. So in the case of complicated shapes, it could be some difficulties. Regarding the construction of the multi-tip tooling, generally we can tell that we have two main types of multi-tip tooling, especially punches, because dies are still same. First, we have assembly construction, when we producing separately the tips and the shaft. Sometimes, of course, we are producing also rotating head, which is separate, and then we are making assembly construction, just to fastening the tips to the shaft in the different ways. I will tell about that in a moment. And the second design is a monoblock design, which we are receiving by machine out of the single piece of steel for the punch. So generally it looks like a conventional punch, but with the more tips inside. Of course, this is some consideration which we need to take into account when we are choosing the design. So of course the size of the tablet and the tool type, because from that we are receiving number of or maximum number of the tips per punch size. Then the second is the maintenance and operational procedure of the equipment, because especially I'm talking about cleaning, the cleaning of the tooling after the installation of from the tablet press. Because if you have a monoblock design, of course, this is a very easy cleaning like a conventional punch. But with the assembly design, generally you should disassembly all the parts, clean them, and assembly them again, which gives a lot of work. Okay, especially if you have more tips. Let's say you can imagine if you have 10 or 15 tips, it is quite time consuming. And then, depends on the ease as you would like to have in the company with the cleaning procedure. You can choose assembly construction or monoblock construction. Of course, the single monoblock design is available in the fewer design for the different tablet shapes and diameters, because here is the monoblock double tip punch. So as you see, we need to keep enough distance between the tips, because in the production of the tip of the punch, we need to go here with the tooling for the machining. Okay, for example, milling tool. So if you have assembly construction, maybe not for the two tips, but if you have a couple of tips, it would be much easier to have assembly construction than the monoblock construction. Here you have two pictures. On the left hand side, you have a monoblock design for the 3 tips, and here on the right hand side, you have this assembly construction. By the way, the tips is fastened to the shaft by the cap. So you have three different parts of the punch. Here you have on the detooling 55 tips for 1 millimeter micro tablet, usually used for the filling of the capsules. Okay, but this is the largest tip number we ever produced, 55 1 millimeter. Generally, one of the benefits of the assembly construction is that when you damage one tip, you can change only one tip, because this is removable. So making this cost very low. But of course, if you have monoblock construction, if you damage any part of the punch, you need to replace whole punch, which is more costly. But you need to remember, of course, that you should keep more or less same procedure like for the normal punches. If you have a set of the standard punches operating in the tablet press, and you have a couple of spares in the set, so you need to circulate all punches. I mean, not in the same batch, but after 1 or 2 batches, you need to change couple of punches because you would like to have same uniform wearing of the whole set, because from the if you damage one punch from the main set, you need to take the spare, and if you're using this main set for the long time, when you take the new punch, the working length could be the significantly higher. So then you can have the problem with the weight control of the tablet. So generally, the rule is to circulate all the punches from the set plus spares, just to keep same wearing extent, let's say. It should be like that also for the multi-tip, because if you have a couple of the tips as a spares, time to time you need to use them. So you need to disassembly, put the new tips, and put that to the one or two batches, just to keep the same level of the wearing. So it could be quite problematic. Okay, what is the construction? Here is assembly construction with the external cap. So you see here the tips. You see the cap, and the cap is fastening to the shaft by the fastening pin. Only one pin, and of course we add so-called orientation pin, because all these tips, especially if it is more than two, should be orientated in the same way as before disassembly. So we have orientation pin, which is quite easy just to make assembling again in the same order. And you have the key here and the barrel. Here you have a 2D drawing. So on the 2D drawing you see what is the inside of the assembly construction of the multi-tip tooling, and you see here that the tips has a colors in the end, and those colors are just push on the direction of the shaft, and then secured by the cap and pin. Here we have assembly construction when we install the tips directly to the shaft. Especially for the larger diameter of the tablet, we are choosing this construction because we can put more tips. So we are just drilling the holes on the face of the shaft, and then we put the tips and secure the tip by the one or the couple of the pins. And we have here internal cap, which is going to the shaft, inside to the shaft, and we fasten this with the screws from the face of the shaft. Well, it has some drawback, this construction, because you have from the face of the shaft you have two screws, and of course those screws just limited the area which you can use for the next tip, but also, as you see, these are screws. So it is a risk of accumulating of the product inside the screws and then the degradation. So this construction is not used very often. Solid construction, this is nothing to add here. You have the construction, the punch made from the one piece of the steel, so this is not, you cannot disassemble that. Rotating head, as I said, I explained that for the before. So this is just how rotating head looks like. This is a different way of the assembling the rotating head.
It could be only 2 pins. It could be some pins with the combination with with some metal pieces, metal balls, or we have the special design, which is a patent pending, which is some special connecting with the head to the shaft, which gives much more mechanical strength and lifetime for this construction. Just to mention that rotating heads are used also for the standard punches, because standard punches, especially when of course you have a key on the punch, especially for the shapes, okay? Because then if you secure the position of the punch by the key, then you can have the problem that the compression roll will go exactly in the same way through the head. So wearing out of the head will be much quicker, especially with the very high compression forces. When you have a rotating head, of course, this is like in the round tooling. So compression rolls goes randomly because head is rotating, so the lifetime of the head is much longer. Of course, the customers are using rotating head for the standard punches only in the case when they have a very high compression forces, so the heads are wear out or damaged much quicker than the rest of the punch. So then they can just replace only the heads. Well, generally, but as I explained, generally it is a very good solution for the lower punches, for the multi-tip, because then you have all this stress which usually are on the tips go down to the head. Well, multi-tip dies, this is not very big deal, because you need to have just more holes which is drilled on the die. The only one difference is that for the low diameter tips, for example 3 millimeter and below, we are making undercut in the die, as you see on the right hand side. Why? Because we have a very thin tips, so the bending of the tips is very big risk. Of course, I'm talking only about the lower punch, because on the lower punch the tips are longer. So just to limit this risk, we would like to shorten these lower tips, just to give them more mechanical strength. That is why we are making undercut, so the lower punch can penetrate the dies going to the undercut, so you can decrease the size or the length of the lower tips. And in the end, I would like to show you the table. This is just the table which gives you the idea how many tips you can put on different standard of the tooling. And of course, the number of tips also depends if the punch has here this bellow or seal groove, because if you have a bellow or seal groove, this is a little bit less material to put the tips. So generally you have here for B tooling and D tooling without seal groove and with seal groove, the maximum number of tips you can put for the different size of the tablet. So you can see that for the B tooling, generally we can make multi-tip when the tablet diameter is 9 or less. Okay, for the Euro D tooling, of course, 11 and less. Then, of course, the tablet became too big, and then you cannot put more tips than one on the tooling. So you see here that for 1.5 millimeter of the tablet, you can put 28 tips on the 28 tips on the B tooling and 37 on the D tooling, and I mentioned 55 tips for D tooling for 1 millimeter tablet. So this is quite a big amount. Okay, so it was and you have here also the different construction in this table: solid construction and assembly construction. So this is just for for some orientation, let's say, and information how many tips for the different tablet size you can put. But of course, if you have any question, we can calculate this for you, just to give you the idea how it can be increased. I would like to, as a final remark, because we talk about these capacity factors in the beginning, and I said that these are very conservative, and maybe I should stress it once again that this is a very dependent on the product and the flowing of the product. So we have the application. We had an application in our together with our customers. Then, for example, 2 tips gives the factor 2, not 1.5, but 2. Also, 3 tips give the factor 3, not less. So it means that for the very easy, non-problematic product flowing very well through the tablet press, you can even expect this factor, which is same as the number of the tips. Okay, so this is generally all I would like to say today about the multi-tip. I know again that this is a lot more things and maybe a lot of questions from your side, but as I said, we have a limited time, so this is let's say just too material to for the discussion and remembering. Okay, thank you very much, and then we can start the question and answer session. Okay, the question is, as you know, the compression force will be increased according to the tip quantity. Is there any percentage limit on this? Well, generally, as you know, the compression force or the maximum compression force depends mostly, let's say in the 80% from the tablet size and profile. The rest of 20% we can a little bit manipulate with using the different steels and the different heat treatment. So generally, when we have very high compression forces or very high request for the increasing the compression forces, we are using usually the best material, which is for the resistance for the braking, for example, S7. And also we are making a little bit less hardness on the tip, which gives more flexibility. So generally, if we have the compression force for the tablet, let's say we have 1 millimeter 8 millimeter round tablet, and let's say, I don't remember the exact values, but let's say that our maximum compression force, this is 24 kilonewtons. If you have two tips, you can double these compression forces. So generally we can use same compression force per one tip, like we are using for the standard tooling. So as I said, you are multiply the compression force, maximum compression force for the tablet by the number of the tips. And this is a general rule which can be used, and we recommend such forces for the customers. Okay, this is a question regarding the rejection of the tablets due to poor quality of press process. So the question is generally when we are using automatic rejection of the tablet, of course, when you have a weight control, what is working with the multi-tip? Okay, it is working in the same way. So one pulse of the compressed air is used to reject the wrong tablets. And of course, regarding the rejection and the problem with the tablet weight, we should be very careful because, of course, the control system of the tablet press will not recognize that this is a multi-tip tooling, of course. Generally, as you know, this weight control is realized by the measuring of the compression forces. So if from the multi-tip tooling, let's say we have 3-tip tooling, and one tip will give you the wrong tablet, the system will recognize all the tablets which is produced in this stroke in the given station as a wrong. So all those tablets will be rejected as a wrong. So even if only one would be wrong and the two good. So generally, we need to control if we have no problem with the working length in a punch with all the tips, but also we can validate this process. And the validation is quite easy because sometimes with some customers they need to validate the rejection system. So we are producing one punch which is on the propose has the wrong working length. So we are sure that all the tablet produced by this punch will be rejected. So of course we are giving the special sign as an embossing, like for example X. So if you have 2 or 3 tip tooling with the wrong tips, with X embossing, and you put this to the given station, then you start the production and you see if your rejection system, weight control system, reject all the tablets marked with X. If yes, the process of rejection is validated. So again, it's working pretty same as for the standard punches rejection system, but it can be very easily validated. Question is, the ejection force will be also increased according to the tip quantity. What do you think? Adding powder lubricant to the formulation, for example, magnesium stearate to tapered dyes and line dyes or different materials? Well, generally we can say that that this is not need for the altering of the formulation. I mean, if you are producing the tablet with the standard tooling, with the formulation, and it flows good, and you have no problem in the production, in the compressing, you can use same formulation for the multi-tip. So no need for the altering. Of course, tapered dyes would be very desired, let's say, or recommended, because generally the tappers gives us some more advantage, and one of the advantages to reducing the ejection forces. Line dyes rather not, because it has no very big influence. Maybe if we are using, because line dyes is the only possibility to make any coating on the inside the bores is the hard chromium, okay? Because generally PVD coating is not working in the dice bores because of the length of the bore, so you cannot receive same same thickness of the coating through the profile of the bore. So different materials, yes, sometimes we had maybe not in the multi-tip, but we had a problem, or one of our customers had a problem with the ejection forces, quite significant problem. So when they use ceramic dyes, the problem was disappear, because it was much better regarding ejection. So I think that this is an answer. Okay, so regarding the question is max tablet size round and oblong for B, BB, and D. Well, generally you can look on the table which I gave as a last slide. Well, generally it was for the round tooling. Oblong tooling, I mean, what is very important. And of course, we need to take into account the size of the die, because B and BB, because this is the different external diameter. Generally, the rule is that between the holes, or between the bores in the die, we should have at least 2 millimeter wall thickness. Also between the external diameter and the end of the bore, 2 millimeters. We need also take into account that we have installation groove. Okay, so it will be a little bit reduced. So for the oblong tooling, we need to calculate mostly what is the limiting factor is the minor size, okay? Because the minor size gives us the number of the tips which can go in die, because the longer axis, or the longer dimension could be almost on the size of the shaft, so 19 millimeters, or a little bit less, maybe 18.5 millimeters. But 19 millimeters we made once or twice. So generally for the detooling and even 20-22 millimeters for the major axis for the detooling. But as I said, generally you can just refer to this table which already Carolina put for you for the downloading. And if you have some special question regarding the oblong tooling, just please send us the request and we can calculate this for you. Well, this question I have is not probably connected with the multi-tip, but this is a case of oval-shaped tooling under cyclic loads, and then cracks is initiated at a regular pattern for the different punches with same pattern and break. Also, side keyways loosen. What would be the possible cause and remedy? I think that the first thing we need to take into consideration and check this is the tooling alignment, because the tooling alignment is very important. For example, if this is the turret which works many years, you can have a problem. For example, that the punch guides or the die guides in the die table are a little bit already lost the diameter. So the diameter is bigger. So if you have a bigger diameter for the upper punch, so the upper punch will be wobbling a little bit. Also, if you have the damage in the keyways, it could be the problem that the alignment will be not exactly ideal. And then if you have a lower punch, so if you have a problem with the too big size of the guide, so the lower punch, instead to be aligned to the die, will be a little bit on the angle. So you have a lot of stress on the one side. So then it would be the reason for the breaking. And of course, if you have a die which is die guide which is too big, so when you install the die will be pushed from the alignment. So again, you will have the problem with the upper and lower punch alignment, and then it could initiate this breaking as you put here. Also, it could be the reason for the loosening of the keyways, because then if alignment is wrong, the keyways is not the keys is not working properly in the keyways, and then it could be some damage on the keyways or the damage in the keys. Okay, this is a question regarding the specific requirement of the process validation of the using the multi-tip punches. And well, generally I already explained the validation of the weight control. So it could be validated in the way of having the let's say a validation punch. And the rest is exactly same like for the single tips. The question is, what is the view of state authorities, FDA, SQL, to use multi-tip punches? This is no regulation on that. So generally is I don't know any comment from FDA or any other authority which will give any specific topic regarding the multi-tip punches. So probably if you have an audit, of course you need to just present all the data, and you need to present that you have a validation, especially for the rejection system if you have a weight control, and of course the measuring procedure, and just to show them that you are controlling the tooling in the right way, and the process. That's it. So this is not no regulation and no other comments from authorities about the multi-tip. Well, this question was already answered. What is about the automatic weight control in the tablet press? It is suitable for the multi-tip punches. Of course, I answered that you need to validate that, but generally, yes, it works properly with the multi-tip. Well, this is a question regarding if we can use the multi-tip tooling on the theta segments, how many tips, shapes, etc. Well, generally, of course, we can. So this is not any restriction, let's say. So of course, you have a different situation because you have a segment instead of the typical die table, but the mechanism of the working is same. So we have the multi-tip tooling, punches, and we are making on the area when we are normally making or having the dies in the segment, we are making the number of the bores, which is corresponding to the number of the tips, and that's it. And of course, as for a segment, we need to keep an eye on the angle of the key, because this is very important. It is more strict than in the normal dice solution, but everything is exactly same. What about increasing the deviation in tips height of the tips by the time? I already discussed that. I think because I said that we need to keep attention, let's say, about to control the working length of the each tip in the good way, let's say, to be sure that the tips are wear out quite evenly. If not, we need to replace the tips, and of course, this deviation or this fluctuation on the tips working length is more risky, or give us more risk in the assembly construction. Okay. In the solid construction, this is less probable that the tips will wear out unevenly. So generally, we need to control the punches. To make a measurement and so on. Exactly, procedure should be exactly same like for the standard tooling. And of course, here we have a little bit more work because we have a couple of tips, so we need to have just a reliable method for the measuring. Mm, okay, process validation. What about the tablets collection for evaluation of the validation? What is your opinion? I already said when we have this validation punch, so with the special embossing, so you can see if all the tablets which is rejected by the weight control system is you can find in the wrong tablet channel or wrong tablet drum. So this is like that. I have a question which I already answered regarding this shape tooling under cyclic load and cracking. So I think I answered this question. Okay, this is could you repeat the undercut design? Okay, it's no problem. We are making undercut on the die. Of course, then you cannot use both sides of the die. You can use only one side of the die, and generally, of course, I have no example here, but let's say imagine that this is a lower punch. This is in fact lower punch, but with the much thinner tips. Okay, so the tips are quite long. So if the tips are thin, let's say 3 mm or less, then the bending risk is quite large. So just to have a possibility to increase the strength, mechanical strength of the tips, we are making those tips a little bit shorter, okay? But of course, we need to remember that those tips needs to reject the tablet from the die. So if they are too short, it will not happen. That is why we are making on the die, we are making the undercut. So we are just removing the material inside the die and making the compression area shorter. And then the punch can penetrate the die, not like normal till here, but till here, because we have undercut. And this part of the punch will also enter the die. So it compensates the shorter tips. That is why the lower punch can eject the tablet, and the tips are mechanically more stable. So generally, this is a idea, and of course, as I said, we are doing that on the diameter of the tablet, which is less than 3 mm or 3 mm and less. Sometimes maybe 4, but generally for the very small tablet, because then what do we lose for the not using both sides of the die? We gain because our punch is more stable and not bending too easy. If there is need to lubricant optimization, I believe that you are asking about the formulation or the lubricant substances in formulation. As I said, this is not the necessity to alter any composition of formulation. So this is the case. The question is, can we able to run multi-tip punch on compression machines at same turret speed of a single tip? Yes, sometimes we can. As I said, it is a very product dependent. So generally, depending on the size of the tablet you have, and depending on the number of the tips, of course, because of course number of the tips just gives us the number of the whole bore on the die. And if you have much more holes to fill, then you need first of all maybe you should work on the design of the feeding paddles, because the feeding paddles gives you some efficiency in the filling of the dice. But if it would be not enough, you need to slow down a little bit just to give enough time to the feeding device to feed in the correct way the die bores. Of course, if you have, let's say, 8mm or 10mm tablet, it would be much easier. But if you have, let's say, 3mm tablet and you have, I don't know, 10 or 15 bores, holes in the die, then it would be much more difficult. So most probably in higher tip numbers or the hole numbers, you need to slow down. But we are talking mostly about the small tablets and the higher number of the tips. If you have 2-3 tips solution and your product is flowing through the tablet press in the right way, it should be no problem to operate in same speed. But as I said, this is case by case. Okay, also not connected with the subject, but the question is, do you have any FDA certificate for the polishing paste? I need to check, because definitely for the polishing media, because we are delivering also the automatic drag polishers. Okay, so we are selling also the polishing media as a walnut shell granulate, for example, and polishing paste, and some impregnation oil, which is used as a media for the polishing in the automatic drag polishers. So generally for the let's say polishing granulate, like walnut shell granulate, no FDA certificate is available at all. For the polishing paste, I need to check, but if this is an FDA certificate, definitely we are using the paste with the certificate. You said that multi-tip could be used with the segments, but do you have any experience how it works in the production? Of course, yes, we have. I mean, not direct experience because we are not producing that, but we are not producing the tablet, but only the tooling. But of course, we are just delivered a lot for the different customers, multi-tip segments and tooling for the segments. So I know that this is working in a good way. I mean, they are not reporting any problems. I wanted to ask if we need to increase feeder speed to make constant charge. Yes, sometimes yes, but as I said, Generally, you need to increase the feeding because we have the more boars in the die to feed. So sometimes we need to increase the speed of the pellets. Sometimes we need to modify the shape just to give the increasing feeding. So it depends. So case by case again. Okay, so thank you very much. I think that our time is over. So again, thank you very much to join me in this presentation, and thank you for your time and interesting questions. As I said, if you have any request or any question which came to your mind later on, just don't hesitate just to send email to me. So I will try to answer as quickly as possible. So thank you once again, and see you in the next webinar. Thank you very much. Take care. Stay safe. Bye.